Kalau ada apa-apa masalah, transfer only energy. Okay, without transferring matter, particles oscillate about a fixed point. So everyone knows that one, kan? Okay, so only energy is being transferred, right? And then what is important in this topic is, okay, you look at this right now. So first you need to know, okay, let's just recall about amplitude. What is amplitude actually? So if anyone can answer me, which level shows an amplitude? Okay, level 1, level 2. Okay, level number 1, yes, A, kan? Okay, so amplitude, okay, you must make sure you know where to measure amplitude. So you measure amplitude from the origin, okay? One wavelength. What is wavelength? So wavelength is the distance. So it's distance. Okay, distance between two consecutive crests. Okay, consecutive and successive is very important, right? So it means that if we start here, so the successive one, the successive peak is the wavelength. Okay, next, period. Okay, so don't confuse between period and wavelength. So wavelength is when we have distance, okay, graph. But when we have time graph, okay, displacement against time graph, what we have, okay, is period. Okay, so period. What is period? So this one, okay, you are going to use this word ataupun this physical quantity throughout physics. Dalam topik-topik yang lain pun kita akan guna period. So this is a very fundamental, very important terms. Okay, so what is period? Period is the time taken. Time taken for what? For
one oscillation complete.
One complete oscillation. Okay, very good. Siapa tu? Okay, dia mesti sebut complete. So kena complete lah. So tadi macam ni successive tu, if I choose here, I start from here, so I have to stop at the successive peak. Successive tu maksudnya the next one, kan? Tak boleh berselang-selang yang lain. Okay, then don't confuse that one with frequency. So what's the difference between period and frequency? Kadang-kadang this one nampak macam alah ini je pun. Tapi inilah yang kadang-kadang student selalu confuse, especially the definition lah. Right? So period, okay, it is related to frequency. So how it is related? So this is the relationship. Okay? Frequency is 1 over period. But look at the definition. What is the difference? Okay? So kalau period is time taken, okay, period is the time taken. So what is frequency? So what is frequency?
Number of complete oscillation in 1 second.
Yes, exactly. So what's the difference between them? Okay, so bezanya this is when you answer about period, okay, so you must mention the unit in second or whatever the unit is. Okay, usually we use second. Okay, it can be minute, it can be in hour. Okay, depending on the question. Now, frequency is not really about time, but it is per time. So frequency, what's the unit? Anyone?
Hertz.
Yes. Okay. Right. Okay. Your teacher should prepare present tu. Ada seorang saya rasa suara yang sama dia yang jawab tu. Okay. Bagus. Okay, so yes, exact. Okay, well done. So the unit for frequency is hertz. Okay. So, alamak. Okay, sorry. Mana tadi? Okay, so ni tengok So, you need to know 1 hertz equals to 1 per second. Okay, so this is the fundamental lah. Okay, don't confuse about period and frequency. Next, okay, when we talk about wave, we talk about speed of wave. Saya rasa Cikgu Zaimah masuk lah. Assalamualaikum Cikgu Zaimah. Okay,
Waalaikumsalam.
So, formula of speed. Okay, speed is F lambda. What is F?
Frequency.
Yes, F here is frequency. Okay, and this one, the wavelength. Right, so this is not that difficult. So this is, I'm sure you are familiar with this, but are you given the formula in exam IGCSE?
No.
Okay, so
No.
you need to know. So right now, saya hopefully by now kan students dah ada flashcard ke ataupun anything formula equals to F lambda. So that's the formula, right? Then you need to know the relationship. Okay, so I'm sure you know how to look at the relationships, right? Now this is an example question that we have. So this is very direct question. Okay, so apa? So everything is given to you, and then you just use the formula, and then you include all the given information. Okay, there is no trick here. Tak ada. Ni dia bagi tahu V, and then the question asks you to calculate frequency, and you are given wavelength. So this is the wavelength. So no trick. So that's very simple. Now let's look at question first example, yeah. So actually I get this question from this is past year question, and I have so this one number 7 because this is in my module lah. Okay, so far okay sekarang?
Okay.
Okay, right. Okay, figure 6.1 represents a transverse wave drawn full size. Point X represents a point on the wave. On figure 6.1, mark clearly the directions in which point X moves. So, right, we want to mark the direction in which point X move. So that's the point X. So how do you think the arrow should be directing to? So now ni kita nak buat soalan satu. Okay, this is kita nak tengok figure 6.1 represents a transverse wave. So this is transverse wave. And then dia kata kat sini drawn full size. Okay, so maksudnya it is according to scale. Okay, dia ikut scale. Now, first question. On figure 6.1, mark clearly directions point X move. So there is a point here. Okay. Right. So if that point, okay, so if this is transverse wave, okay, so how is the point will move? How is the movement of the that point do? Kalau that is a particle, so what is the direction of the particle? So since this is a transverse wave, so the particle will move up.
Up and down.
Up and down.
Okay, so because it is transverse wave.
Oh.
Okay, so it's as if you have, tadi I watched just now some cikgu share ni So boleh tengok dekat sini. Okay, movement. Saya takutlah nak tekan sebab nanti takut internet slow terus. Okay, actually I want to show you lah kan. Tapi awak dah tengok tadi kan. So kat gambar ni, so if this is a particle, so this particle will move up and down. The particle will not move with the wave sebab only energy travels. Okay, so let's go back to the question. Use figure 6.1 to measure the wavelength of the wave. So if this is in your examination, so it states clearly ni, dia dah mention kat sini, you have to measure, right? So you use a ruler, you measure wavelength. Tapi kat sini, what is the skill that you need to know? What is the knowledge ataupun what is the concept that you need to know? Okay, you need to know what is wavelength. What are you going to measure? So you can choose any
point.
Any point here. So if let's say you want to choose this point, okay, so you should stop at the, kat mana? 1, 2, 3, 4.
2.
Yes, you should stop at 2. Okay, and then you measure lah. Awak letaklah awak punya ruler. Okay, and you measure. Right, so that's why kat sini kata measure, and you need to know what is wavelength. The frequency, question number 3. the frequency of the wave is increased, describe how the wave pattern in figure 6.1 would be different. Okay. So now frequency is increased. Describe how the wave pattern would be different. So will you see more waves or less waves?
More waves.
Okay.
More waves.
Right. So you all dah jawab kan ni kan? Okay. So sekarang kita nampak we see many complete a cycle. So kita ada 1, 2, 3 and 4. Okay, kita ada 4. So if the frequency is increased, okay, therefore you will see more number of complete. So your answer should be more waves. More waves will be seen, ataupun you can say shorter wavelength. Alright, please tick in a box next to any transverse wave. So this one is the knowledge. No. So what is the which one is transverse wave? We have light and radio only. Sound is not. Okay. Now state the wave that cannot travel vacuum. The answer, it must be sound. So now you know sound must for sound to travel, sound wave to travel, we need medium. Okay, and then we need types of waves. Okay, we have transverse wave and we have longitudinal wave. Right, I don't think I'm going to go any further on this one. Okay, so transverse wave, tadi kita dah mention lah, kita dah bincang lah tadi. Okay, so the motion of the particle vibrates at its position, okay, but it vibrating perpendicularly. Okay, and how is that different with longitudinal wave? Okay, so longitudinal wave, so this is we have compression and refraction. Okay, compression and refraction. So what is I think the most important thing that you need to remember for this one, you need to understand where. So sometimes if you may be asked to label the wavelength. So if I start here, okay, kalau saya pilih nombor ni, where should if I want to make a line, dekat mana akan menunjukkan, dekat which point, which line will be the I will have a complete wavelength. Itu sajalah for this one yang students kena tahu. Okay, kat mana? So let's say this one number 1, number 2, number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So which one will be the one wavelength?
From 1 to 14.
To 14. Okay, right? 14 ke 13?
13.
Boleh angkat tangan lah, cikgu boleh tengok nanti. Who says we should stop? Siapa angkat tangan lah, siapa kata dekat 14 kita ada one wavelength? Okay, so okay, right. So 14 ke 13? Everyone agrees?
13.
Kita nak tentukan one wavelength. Okay. Okay, so kita ada yang jawab 13. Okay, so tengok ni Okay, what is given? So kat sini dia buat sini. Right, and then kita nak kena tentukan betul-betul ni kat mana jadi one wavelength. Ini sajalah bagi cikgu yang student akan ada masalah sikit lah ataupun dia tersilap ke apa. Okay, you kena start wavelength is the distance ataupun displacement for one complete oscillation. compression. So this one complete tu yang penting tu. Kita kena complete. So kalau kita start dekat compression punya area, so kita start dekat 1, 2, 3 yang dekat 1, 2, 3. So kita kena stop to compression. Okay, so itu kita ada one wavelength. Sama juga dengan ni. Jadi kat sini from the compression ni kita ada 1, 2, 3, 4, 5. Okay, 1, 2, 3, and then 1, 2, 3, 4, 5. So this will be our one wavelength. Okay, be careful with that one. Alright, so the only example that we know so far adalah sound wave lah. Okay, and sound wave need a medium. Okay, do you have questions? Right, so if no, please continue. Now, a long spring is fixed at one end as shown in figure 5.2. The spring is moved towards and away from the fixed end repeatedly. The compressions and refractions on the spring at a particular time can be seen. State the type of wave in the spring. So this is obvious. The answer must be longitudinal. Okay, very good. And state one example of this type of wave. So we have mentioned this one, okay. And this shouldn't be any problem. Okay, that's easy. Use the scale in figure 5.2 to determine the wavelength. Tengok, soalan-soalan yang berkisar tentang longitudinal macam ni lah. Okay, so what's the answer? You have done this one, yeah? So what's the answer, class? Students? Are you there? Ini masih berada di sini ke?
Okey.
Okay. Dia senyap je nervous kan? Okay, takut dah terkeluar. Okay.
Maybe unmuted teacher.
Akak share macam ni. Sebab I am still online ataupun I was working. So, anybody, you can share with your teachers lah dekat chat room tu apa sebab I cannot read your chat room ataupun you want to say out loud. Yes, Muhammad Afiq ni good student ni, calon A-star kita. Kan? Cikgu luar pun tahu dah. Okay, so what's the wavelength? Afiq tadi?
In my opinion, the answer for C3 is 100 centimeter. Am I right?
100 centimeter. Okay, so the answer is okay, so this is quite tricky. Trick part dia macam mana tadi? Trick part dia ialah kita nak tentu wavelength. Okay. Now, Afiq, thank you for trying. So kita tengoklah awak nak. Okay, so saya zoom dekat sini. Okay. Right. So which one? Alamak, gambar. Which one you start untuk dapatkan wavelength? Awak pilih satu point. If I were you, I will choose the more obvious lah, the most obvious one lah. Di sini, saya akan pilih sini. Right, so what's that reading?
0.5.
500
Okay, so that's
centimeter.
0.5. So I must stop at the same face. Kan? So mana ke yang same face tu? One wavelength. Mana? Is it this one?
Yes.
Betul tak kalau saya kata sini?
Tak.
Salah. Okay. Right, kenapa salah? That is not yet one wavelength sebab kita start after refraction ni. Jadi, this is refraction. So, you must stop dekat mana? The first one before the first one after refraction. So, which is that point there. Okay. So, what is this? Yep.
Why 0.5 cm? 0.5 m kan juga.
Okay. Sekejap. Itu jawapan sekejap. Yang ni berapa sekarang? 1.1.
Bukan cikgu. Yang cm tu cikgu. Bukan m ke cikgu?
Unit dia bukan meter ke?
Ya.
Terima kasih. Allah cikgu.
Tu yang tu cikgu bukan.
Ya. Okay, sorry.
Cikgu.
Ada je nak test yang lain tu.
Okay, terima kasih. Okay, so now you just minus off. Okay, wavelength dia adalah You boleh buat jalan kerja jangan risau. Kadang-kadang student dia macam tak nak, dia tak jawapan je. So buat jalan kerja kat sini and be careful the unit. So what is the answer? 1.4 minus 0.5 is
90.
2.8.
huh?
900 cm. 900 cm. 900 cm.
90 cm.
Okay, so jawapan dia. Okay, and then
0.5.
you have to convert. So sebelum tu awak
90
buat dulu lah.
cm.
Kat situ, okay. So nampaklah dia punya triknya 1.4. So that gives you 0.9 meters but you, okay, and then dia 900 centimeter. Okay, so for this kind of question, dia ada range je lah. Jawapan dia ada range. So depends. But be careful, alright? So you must make sure that students ada tendency nak jawab macam ni. Cikgu ni wavelength. Salah. Okay, so that's wrong. Okay, so saya fokuskan pada mana kesilapan biasa belajar lah. Right, so again another question, something like that. So awak dah cuba kan? So at the center of compression, mark across and label it C. Okay, so that's not difficult. Kat mana kita nak bahagian compression? Awak tahu compression dekat bahagian mana ya? E, B, C, D?
D dengan D.
D dengan D.
Yes, so you can choose mana-mana lah. You may want answer kat sini. Dia kata mark across and label it C. So awak kena letak cross lah. Cross and then label C. So be careful. Read the question. Dia suruh label, dia suruh mark with a cross. Okay, at the center of the refraction, mark across and label it R. So this shouldn't be any problem jugalah. Okay, so this should be the mark across and label it R. Draw a double-headed arrow to represent a distance of 0.9 meters. Okay, kenapa dia soalan macam tu? Why the question is like that? What is given to you? Okay, sometimes students punya masalah ialah bila dia tak baca soalan from the beginning lah. So what is the first, what in the information given? What is the information given? Yeah, So figure represent a sound wave of wavelength 0.45 meter. So that is very important. That's why lah dia kata tiba-tiba dia nak measure. Okay, you represent a distance of 0.9. So what knowledge do you know?
Wavelength.
Yes, masih lagi berkisar tentang wavelength. So we have to understand the meaning of wavelength. So wavelength is one complete oscillation. So kita nak kalau 0.9, that means we have how many wavelengths?
Two.
So we have two wavelengths. Therefore, you must draw a line of two wavelengths. So I start kat sini saya pilih yang ni sebab ni macam nampak very obvious. So di sini jadi 1. So the first yang tengah-tengah yang compress ni pun okay, akan jadi the third. Jadi my line would be ke sini. Tapi soalan nak macam mana? Double headed arrow. So buatlah. Nak label apa? Two wavelength ataupun you label 0.9 meters. Okay, right. Do as what the question asks you to do. Okay, the frequency of the wave is 750 Hz. Calculate the speed of the wave. So this is not difficult. Okay, so that this is very direct. Okay. Right. Okay. So this is another example of tuning fork. When you hit tuning fork, the tuning fork will vibrate. So the vibration is actually in longitudinal. So you will get longitudinal wave. Okay, and then next you need to, in topic waves, you need to understand the word, the term wavefront. What is wave? So I'm sure if you look at these diagrams, you understood already kan? Dah faham dah. Okay, so wavefronts actually are the imaginary lines kan? You don't really see it, tapi awak tahu dia. Dia adalah imaginary lines. Imaginary lines apa? lines are joining all points vibrating at the same phase. So now you look at P and Q here. So this is the one I'm referring at, yeah. So P and Q, that imaginary line, dia walaupun imaginary tapi ada drawing dekat situ sebab kita nak tunjuk lah kan. Tapi kalau awak tengok betul-betul dalam ripple tank, you don't really see the line tu. Awak tak nampak pun line tu unless awak tengok tenung kan. Okay, sekarang ni P and Q, that line is formed by joining all points vibrating at the same phase. So awak tengoklah here kat sini kan. So apa ni? So this is peak. So next kalau ada lagi satu wave macam tu, ni pun peak. Ni pun peak. So all the peaks tu, so this peak, tak nampak. Okay, ni membolehkan kita buat one line connecting all the crosses tu. So kita dapatlah wavefronts. Okay, so we have two types of wavefronts, plane wavefronts and circular wavefronts. And the other one that you need to understand. Okay, so when you draw, if you, let's say you are asked to draw the wavefronts, you must make sure the wavefront is perpendicular to the, what is the red one? The red one is the direction of propagation. So wave, so if waves travel this way, so kita buat arah macam tu. Selalunya kalau kita buat soalan dia kata, okay, draw the wavefront. Awak tak boleh lah draw macam ni. Cikgu saya, ni my wavefront. Salah. Okay, so apa dia punya konsep? The wavefront, the line must be
Perpendicular.
So you must make sure lah. Okay. Kalau it's circular pun sama. Dia perpendicular. Okay. Next kita masuk pada reflection of waves. Okay. So reflection of waves. So this is the easiest of this phenomena. Okay. So this is a phenomena of reflection of waves. Okay, first thing you must remember, you need to recall the law of reflection. This is not that difficult, but kalau if you are asked, but in IGCSE they unlikely to ask you about, okay, state the law of reflection. Jarang lah ditanya macam tu. Tapi if you are asked about law of reflection, you must know 2 points. The first point is angle of incidence is equal to angle of reflection. Okay, what is another point about law of reflection? Susah tak nak hafal? Tak payah hafal. Awak tengok gambar ni, you just imagine this diagram and then you can state law of reflection. Tadi apa? Law of reflection. Okay, first kita kata tengoklah. I equals to R. Okay, so that's the first one. And the second one, kita tengok. Okay, apa lagi yang awak nampak pada diagram? We see incident wave, incident line. We see reflection line. And then we have normal line. So, the second law, the second statement of the law, kita kata incident line, incident ray, reflected ray and normal line lie on the same plane. Sudah selalu lupa yang ni. Okay, tapi tak payah hafal pun. You tengok gambar, tengok apa yang awak nampak. Itu dia. Okay, right. Okay, after when this happens, okay, kalau kita ada satu wave, if we let's say we have a wave and then the wave is reflected. So what happens to the wave, the reflected wave? So kita kata kat sini, ada perubahan tak? Incident and reflected wave. So I have ni saya dah bagi dah kat sini. So tak ada. Nothing is changed. Semua sama except for the direction. Only the direction berubah. Yang lain semua maintain the same. Okay. So this one rough surfaces scatter the light. Ada tak gambar? Saya tak letak gambar Oh. carousel letak dah hilang lah tu gambar dia. Tu kat belakang tu. Okay, rough surfaces. So if you ni gambar dia kat sini. Oh, okay. So this is rough surfaces. Kalau rough surface ada reflected, ada incident ray like this. So you must know how to draw the line. So macam mana awak punya refracted ray tu? Dia akan pergi macam-macam arah lah.
Hello, cikgu.
Hilang
Cikgu hilang. Cikgu. Hello.
Okay, saya
Cikgu.
hilang tadi lah. Okay.
Cikgu hilang.
Where were I? Where was I?
Drawing.
Rough surface.
Drawing ni rough surface. Oh, sampai ke tu. Okay, so now we look at the second phenomena. So this is second phenomena. Jadi macam ni saya macam tak sabar pula nak habis sebab takut you all sangkut you all. Okay, now physical quantity kita ada shallow area, deep area. So kalau student saya kata buat rap sikit lah. Rap macam mana? So apa yang berubah? So shallow, slow, small. Apa yang shallow? Ni slow, ni small. Shallow, small. Awak tak nampak pula saya buat gaya kat sini ni kan? Tapi shallow, small. So that is one thing that you can help you lah. So at shallow, slow, small. Apa yang small? Wavelength. Macam tu lah. Okay. So of course lah at deep area will be the opposite. Okay. Kalau slow kat sini faster ataupun higher, wavelength will be high. Tapi awak ingat satu part je lah. Tak adalah sebab dalam kepala kita ni banyak nak kena isi kan. So kita ingat ni shallow, small. Okay. Right. Okay, so and then we have diffraction. So what is diffraction? Diffraction is spreading out of waves after passing through a gap around an obstacle. Okay, now I have two gaps here. So what is obvious about what is the difference between the two gaps? The
What?
yeah, the width of the gap. Okay, so this one the gap is bigger. Okay, right. So now then you need to know apa yang awak kena faham. Okay, so this is the wave. Okay, if the gap is equal ataupun less than the wavelength, okay, you will have more obvious diffraction. Okay. Kalau the gap is bigger than the wavelength, so the diffraction kita kata less obvious. So this is less obvious. So how do you differentiate tu dengan drawing? So if you look at this, you nampaklah drawing ni berbeza kan? Okay, so kalau more obvious, dia more curve. Then if you are asked to draw, right? So you must make sure the wavelength nak berubah ke tidak? That is the knowledge that you should know lah. Okay? Okay. So yes, thank you. Very good. So if you look at this, wavelength before, after. So after diffraction, the wavelength must not change. Therefore, awak tak bolehlah draw macam ni. Kalau ada student dia macam yelah santai-santai jawab kan. Okay, dia jawab macam ni. So ini nampak macam sama ke salah? Nampak sangat apa? Ketara sangat yang they are not
The same.
They are not having the same wavelength. In fact, ni dengan ni pun lain, ni dengan pun lain. Jadi salah walaupun dia faham. Jadi okay. Katalah awak ni memang bukan Parkinson, awak macam bergegar-gegar tangan, panik kan? Apa awak nak buat? Okay, awak panik, awak buat 3 kali 4 kali pun masih lagi dapat macam ni lukisan awak. So what can you do? Awak panik ni. Masih lagi alamak macam tu. Jadi katalah awak try 3 kali, lepas tu dah takkan nak buat banyak kali, kan mau masa, jadi awak buat macam ni. Ni tips dia lah. Janganlah obvious sangat, ni macam obvious sangat, cuma kalau macam dah tak ada harapan nak buat betul, awak buat macam ni. 1, 2 ataupun awak buat simbol wavelength atau then awak buat wavelength 1 equals to wavelength 2 equals to wavelength. Faham tak? So ini kena mention.
Faham.
Kena mention because we want to show that to the examiner that yes, I understand the concept. I am having problem drawing. Itu dia. Tapi kalau students dia tak tahu benda ni, tu yang dia akan draw macam ni ataupun dan dia tak buat, dia tak tinggalkan apa-apa kan. Jadi sayanglah tahu tapi dia buat macam ni. Tapi kalau dia buat macam ni kan, katalah macam ni. Lepas tu tak label apa-apa. Tapi kita bagi salah juga. Sebab apa? Sini macam dah okey antara ni dengan ni. Dah nampak kalau dengan naked eyes macam samalah wavelength dia. Tapi ni so be careful. Okay, dan if you are asked to draw, my suggestion is you don't draw too many lines. Okay? Berapa line nak kena draw? Berapa enough?
3.
Yes.
3.
Yeah. Cukup macam ni je. Tak payah banyak-banyak. So the more you draw line, the higher the possibility you get it wrong. And then kalau kalau less obvious macam ni, dia punya teknik awak buat je straight, tapi janganlah straight sangat. Kan? Okay, awak buat straight line. Okay, and then make sure wavelength dia sama. Okay, tak payah lukis banyak ni. Okay, and then curvekan sikit that part. Okay, so sebenarnya kita nampak macam seolah-olah kan dia ada sikit lah kat sini. So that's how you draw. Okay, first tip tadi buat straight line and then curvekan sikit hujung and then buat ni sebagai your reference lah. Okay, and of course kena label juga sini. Okay, label to show that you understand. Okay, any question?
No, teacher.
No question. So if you look at the definition of diffraction, it's through a gap ataupun obstacle. So ada obstacle, so this is obstacle. So obstacle, tips nak draw dia, first you buat segitiga kat belakang ni lah. Kan? Okay. Segitiga tu guna pencil je lah. And then you draw a straight line, awak buat pencil, pembaris. You draw the line kat sini and that's enough. 1, 2, 3. And then you curve kan sikit. Yang ujung tu bertemu. Right? So that is not that difficult. Macam mana nak jadikan dia less obvious? Kita punya segitiga tu besar lagi lah. Dia akan jadi less obvious. Okay, so that's about diffraction. Okay, ini semua tak berubah. Kecuali satu. What is the only thing that change?
Amplitude.
Amplitude. Okay. So kenapa amplitude tu berubah? So that can be a very good question lah. Amplitude berubah, berkurang. Kenapa amplitude berkurang?
Because of obstacle and gap.
Sebab ada obstacle. Kenapa obstacle tu? Jadi, so here is the
Dikurangkan energi.
okay, amplitude decreases because the energy dispersed. Oh, dah pukul 4 dah. Kita habis 4:30 Okay.
5.
Oh, pukul 5. Okay, so amplitude decreases because the energy is dispersed to a what? To a wider area. Wider region lah kan, ataupun wider area. So bayangkan kalau kita ada gempa bumi, na'udzubillah kan, the gempa bumi starts from here. Ni, dia start dekat ni, kawasan ni. Jadi, kalau orang yang duduk makin jauh, gegaran. Of course lah makin kuat kurang gegaran kan. Kat sini paling kuat. Dia punya disaster teruk kat sini. Tapi kat sini adalah tapi mild je kan. Dia punya gegaran je. Kenapa macam tu? Sebab the energies begins here kat sini. Energy kat sini is the most. Kat sini ada energy transfer. Apa? Spread kan, the word is spread. Okay, the energy has been spread over a larger area. Therefore, you need to know amplitude decreases. Cara lain apa lagi? Bukan analogi lah, situasi yang buatkan awak senang nak faham. Contoh kan awak dengar radio lah. Diffraction ni always happens kan. You are in your own room. Okay, awak dalam bilik pasang radio kuat-kuat. Kan, awak pasang radio kuat-kuat kan. Beri cikgu lukis. Okay, so mak kat dapur. Dengar awak pasang. Tapi adakah kalau mak masuk bilik, sebenarnya kat dalam bilik tu lagi kuat. Betul tak? Dekat dapur mak dengar tu tak sekuat yang dekat dalam bilik. Kenapa? Sebab diffraction happens but throughout the diffraction process, the energy tu dah decreasing. Okay, energy is spread. Okay, dispersed. Okay, so this is an example question related to the reflection of wave. So,
Cikgu.
Ya.
Nak tanya, yang pasal disperse tu kan? Kalau kita tulis energy is lost to surrounding, boleh ke?
Energy lost to surroundings. Not really what we want lah. Kita nak awak guna perkataan spread ataupun disperse tu. Okay?
Okay.
Tapi the concept tu, tapi awak faham lah. Dia ada energy loss tu. Tapi dia loss macam mana? Macam mana dia loss tu? Okay? Dia loss sebab dia spread. Okay? Alright. Thank you. Okay, thanks. Okay, most welcome. Okay, now the diagram represents plane wavefronts of a water wave about to strike a solid barrier. Which diagram shows the position of the wavefronts after reflection at the barrier? Okay, so if you have tried this one, what is your answer?
C.
Yay.
C.
So that is not difficult. Senang saja. Kita buat apa? Kita buat law dia. Law of refraction kata, and then it will be reflected. So dia punya reflection. Kenapa mesti begitu? Angle mesti sama I dengan R reflection. So mana yang menjawab sana? Oh, macam senang sangat soalan ni kan? Only C kan? Tak ada possibilities. Okay, this is another question. Plane water waves into a deeper region. They travel more quickly in the deeper water. Which diagram shows the wave pattern in the deeper water? So now we have shallow. Tadi macam mana kita nak ingat? Shallow, slow, small. So now we have small. Apa small tu apa? What is small here? The wavelength. So yes, wavelength. Betul? Slow, speed, small, wavelength. Shallow, small. Jadi kat sini small. Awak dah nampak dah, that's the wavelength. So dekat deep region, you must have wider wavelength kan? You must have
Wider.
okay, longer ataupun greater ataupun wider wavelength. Jadi mana ni? B terus cross. Kenapa B cross out? D pun terus cross out. Kenapa?
Wavelength kecil.
So dah tak payah fikir. Sekarang cara saya kata, cara nak kena ingat, kena cakap slow. Tapi you cannot see the motion. So you do sekarang it's either A or C. Tapi if you look at C, if you look at A pun, the wavelength is not
Big enough.
it's not right kan? Okay, sebab saya dah kecilkan ni. Okay, right. So C is the best one. Okay. Right. Okay. Figure 5.1 shows 6 wavefronts Dia bagi tahu ni 6 tu. 1, 2, 3, 4, 5, 6. In IGCSE, not only IGCSE lah, SPM ke final ke sama juga. Now, dia bagi tahu dah 6. Kenapa 6? So kena take note lah. Of a wave travelling on the surface of deep water, the wave is incident on a boundary. So kita ada boundary kat situ with a region where the water is shallow. Okay. So tadi apa shallow? Slow.
Slow.
Okay. Right. Okay. Now on figure 4.1, draw the wavefronts of the wave in the shallow water where the water travels more slowly. Jadi, first, are you going to draw? What are you going to draw? So, if I were you, okay, this is the tips lah. Okay, nak buat line kat boundary ni. Okay, kita ambil straight line ni kan, kita sambung sampai sini. Alamak, tapi dekat sini tak ada wavefront. Faham tak? Faham ke? So, tak apa. Don't worry. Saya ambil pembaris. Okay, let's say mana pembaris saya? Katalah saya ambil pembaris kan. I place my pembaris. Ni contoh lah contoh. This is my pembaris. Okay, saya letak pembaris saya tu atas bawah. Sampai sampailah pembaris tu parallel to the line of direction ni. Okay, and then I draw this line. Sama juga lah. Saya nak sentuh yang ni. Okay. Okay. So I have to the direction of wave. Okay. So sekarang ni this line dia touch. Bukanlah dia macam ada ni kan, hit it kan. Okay, next. Now, where is the direction of the direction will change. Betul tak? Macam mana dia punya change?
Refraction.
Okay, when the refraction happens, so this one slower. When the wave travels slower, so what happens to the angle?
Near to the normal line.
Okay, next. Okay, so this is the first tip lah. So second, yes, I heard just now someone said you have to draw normal line. Okay, normal line. Okay, so that's the second thing. So saya panjangkan sikit lah normal line dia. Okay, is that normal? Normal ke tu? Make sure it's normal lah. Normal to the boundary. Okay, so now where is the incident angle? So this is the incident angle. Now the refracted angle will be larger than that or smaller than that?
Smaller.
Kenapa smaller?
Sebab shallow denser.
Okay, I'm talking about angle ya, bukan wavelength ya. So the angle will be smaller because it moves slower. Jadi angle dia saya buat macam ni lah. Kenapa? Because I want to show ni. Angle dia smaller. Okay. Okay, next. What to do? Kita dah buat number 2, kita dah buat number 3 now.
Draw wavelength.
Yes, wavefronts. Okay, the question asks you about wavefronts. So apa tips yang kita kena draw? So first kita kena perpendicular, bagus. Okay, so perpendicular. Now, you place your ruler anywhere that is perpendicular to the line number 3 tadi tu. Kan? Line number 3 ni awak letak. Sini perpendicular tak? Yes. Jangan macam ni lah. Ni salah lah. Tak perpendicular. Okay. So, saya dah buat tu. Okay, saya buat satu tapi for your information, dia dah bagi tahu sini C.
Dah okey.
Tadi dia nak slow sikit.
Okay. 1, 2, 3. Oh, angle saya ni terlalu kecil ni. Besarkan sikit patutnya. Okay. Sekejap. Sing pula. Okay, sama-sama keep. Okay, next kita buat line tadi. Kita nak draw perpendicular tadi kan? So ni perpendicular tak? Tak. Perpendicular macam mana ni? Ya, tapi line tu kena temukan dengan line atas tadi. Okay, yang ni perpendicular tak? Gerakkan pembaris. Pembaris mana pembaris? Okay, letakkan perpendicular tak? Okay. Okay, make sure ni perpendicular. Katalah awak lukis macam tadilah saya kata. Lukis lah tak jadi. Jadi awak buat ni. Simbol perpendicular ni. Okay. Now, tak cukup tau. Okay, so continue. Okay, awak sekarang ni line yang ni. Yang ni. This one. Ni line number third ni. Dia dah kat atas. Padahal kita nak kena garis lagi yang bawah-bawah ni. Ni nak tunjukkan dia bend. Kan? Jadi the pembaris tu parallel to the ni line tu. So letaklah kat sini. Pastikan dia parallel. Okay. Okay, ni pun kena garis sampai bawah. Enough. As long as you show that yang ni bertemu. Mana yang bertemu ni? Ni. 1, 2, ni kan 3, 4, 5. Yang ni tak boleh lah sebab dia tak nampak region tu. Okay, and then you can label here. Awak label mana? Label sini. Label lah wavelength 1. Sini wavelength 2. Tapi tak payah pun tak apa. Kan? Kita nak bagi tahu wavelength 1 less than wavelength 2. But actually this one is not really important lah sebab awak dah tahu dah. So the drawing dah obvious, nampak dia tak sama. Okay, any questions so far? So ada berapa benda penting tadi? 1, 2, 3 and then 4. Fourth one is the line perpendicular. Okay, and then fifth one, make sure awak join tu bertemu lah ni. Okay, so tak ada question. So that's the drawing. Okay. Figure 6.1 shows wavefronts approaching a gap in a barrier. Okay, on figure 6.1, draw 3 wavefronts. Boleh bagi tahu dah, 3 saja dia nak to the right of the barrier. So, is this, you will get something that is obvious ataupun less obvious?
Obvious.
Okay, so it could be obvious one. Jadi dia kena curve lah. Okay, tak boleh straight tadi. Kalau straight tu salah. Alright. Okay, so buatlah draw 3. 1, 2, 3. Betul?
Betul.
Siapa kata betul? Angkat tangan. Cikgu tak nampak pun lah. Tapi siapa kata salah? Siapa kata salah? Angkat tangan. Kenapa salah?
Wavelength.
Tak sempat. Jadi hati-hati. Kadang-kadang kan kita tahu tapi dalam exam tu penat, dalam exam panik. Jadi bila bila dah alamak nak betulkan sekarang nak kena hantar. Cepat-cepat buat ni. 1, 2 sama dengan tu. Cepat-cepat macam tu. Tapi kalau awak dah tahu daripada awal, hati-hatilah sebab buatlah ikut saiz yang dia nak. Okay? Next, okay, figure shows the gap in the barrier increased to 5 times the gap in figure 6.1. So this new one akan jadi less obvious.
Less obvious.
Yeah. So awak senang lah. Yang ni awak guna pembaris sajalah. Awak guna pembaris, make sure wavelength about the same. Awak buat straight. 1, 2 and 3. Right. Tapi lepas tu nak buat apa? Hujung ni curvekan sikit lah. Okay, buat ni lah. Buat line ni. Buat line ni. So that will help you. Kenapa? Nak help apa? So kat sini awak sambung panjang sikit. Alamak, sambung sikit. Sikit. Okay, lepas tu ni curve kan. So that's how you draw. So that's number 1, the wavelength. Number 2, and then 3, the curves tu.